The research on random intrusion depth detections of Internet of Things based on 3D convolutional neural network. I have four concepts. The first one is introduction. The third one is the designs of intrusion detection model for Internet of Things. And the third one is the experiment designs and results analysis. And the last one is conclusion. And I have an abstract. There are many problems in the individual's Internet of Things, such as low feature extraction rate, low detection efficiencies, and poor adaptability. To solve this question, a random intrusion depth detection method based on three-dimensional convolutional neural networks is proposed. According to NIDS, an intrusion detection model of the Internet of Things is built, through which dispute network data packets are collected, and the principal component analysis algorithm is used to perplex them to reduce data dimensions. Combined with the deep learning theories and technologies, select data features to form feature metric. With this as the input, the random intrusion detection in the Internet of Things is complicated by using 3D convolutional neural network, 3D CNN, and combined with the long and short memories method. And the experimental results show that the F1 value of the detection method is above 0.9, indicating that the detection's accuracy of the method is high. The key word is three-dimensional convolutional neural network, Internet of Things, random intrusions, the depth detection method. And the first one is the introduction. Propose a three-dimensional convolutional neural network based random intrusion depth detection method. The first one is the low feature extraction rate. With the deepening of the role application, the complex network environment innately attracts make it face many challenges, such as the hacking intruders, security values attacks, and warmth and so on. So can be divided into three labels: control layer, the network layer, and the application layer. And two is the raw detection efficiency. And the third one is the poor adaptability. Part 2. Designs of intrusion detection model for Internet of Things. The preface. The network's intrusion detection method. Intrusion detection. The network's intrusion detection enumerates intrusion detection and the distribution, the centralized intrusion detection, and the distributed network's intrusion detection. The network packet collection have two types, the hop type and the network types. The host type includes the system logs as data sources information from the host for analysis, application logs as data sources, and other means, such as monitoring system calls, can be used to collect. And the network type, the data packets on the networks. The network card can be set in mixed model. and this is the NIDS. When storing NIDS, the key is to choose the location of data acquisition section. The following elements: agents, forwarder, monitors, filters, and user interfaces. And the package passing, the data dimension reduction. The step 1 is to calculate MI, MIA, MIR, and MIS of each attribute. Compares MIS with comprehensive mutual information credibility. The step 2 is to use the PCA algorithms to reduce the dimension of metric. And the data standardization. Standardization is one of the most common dimensional processing methods, and the calculations formula is AI, and this is the structure diagram of the data package processing. In 2D convolutional neural networks, the convolution process can be only learn features from the spatial dimension. Performing 3D convolutions and 3D pruning in the convolutions and pruning phases of a CNN, allowing simultaneous computations of spatial and temporal dimension features. And this is the constructions of data characteristic matrix. The feature extraction is an indiscernible step in intrusion detection, which is directly related to the efficiency and accuracy of detection, and thus affects the performance of detection models. The intrusion identification. The construct data feature matrix is regarded as a feature map composed of numbers, and a 3D convolutional neural networks algorithm, 3D CNN, which is commonly used in the depth learning algorithm, is useful in children's regressions, and especially definitions formulas of the combinations operational is as follows. The output calculations formulas of the full connection layer is as follows. In the data of processing stage, the one-dimensional subsequent sequence data types is converted into three-dimensional number-shows matrix form to form the classifier. The first step is data input. The second step is feature extraction. The third step is to classify the branch rows. The fourth, convolutions and pruning can be effectively extra features, but networks intrusion data also has its corresponding subsequent relationship. The third part is the experiments, designs, and results analysis. The data description. At present, KDD99 dataset is the earliest one used in the public networks intrusion detection dataset. The NASL K-D dataset is an improved version of KDD99, which removes a lot of the roundabout data. Model the diagrams of random intrusion depth detection method based on three-dimensional convolutional neural network. And for the two datasets, the first 50 features are constructed using information game. The information game of each feature is shown in Table 1 below. In intrusion detection, attacked samples are regarded as positive samples and non-attacked samples as negative samples. TP represents the number of samples that were originally positive and were predicted to be positive. TN represents the number of samples originally negative and presented to be negative. TP, FP represent the number of samples whose positive classics are predicted to be negative, and Fn indicates that the number of negative samples is predicted to be positive sample. Accuracy. It indicates the proportions of real positive samples in the total number of predicted positive samples. The record rate refers to the percentage of the sample that accurately, positive, and correctly predicted in all the predicted positive samples. F1 measure is a balance point that considers the precision and record the same time, so that both can reach a related high value at the same time. Under the same test data set, use the research method intrusion detection technology based on the Bayesian network, intrusion detection method based on improved mode, and intrusion detection method based on calculation optimization algorithm to conduct random intrusion detection of the Internet of Things and get the detection results. According to the results, calculate the F1 value. The comparison shows that the F1 value of the research method is significantly higher than that the 1-3 comparison methods, indicating that the detection accuracy of this method is higher. The last one is the conclusion. As the network environment becomes more and more complex, the network security accident occurs for means that change constantly, which threaten the securities of the Internet of Things. Therefore, the important role of Internet of Things intrusion detections become more and more obvious. Aiming at the raw accuracies of the intrusion detection in industrial Internet of Things, a random intrusion depth detection method based on 3 dimensions convolutional neural network is proposed. The random intrusion depth detection in the Internet of Things is complicated by constructing the features matrix and take it as an input. Using 3D-CNN and LSTM method, experimental results show that the proposed method have a high detection accuracy. Because in the actual network environment, all kinds of the unpredictable emergencies are uncontrollable. Therefore, in order to further improve the stability of the network intrusion detection model in the real environment, further research is very in need. And as the networks become more and more complex, we have in the structural designs of 3D CNN model for the large size of the convolution calculate in the classic level architect, and the 2 constantly conversions and pro-stack method are proposed to overfitting. In this paper, the depth varying coverage layer is to replace the combinations convolution layer, and this the bench knowledge layer is as to this one. And therefore, in order to further improve the stabilities of the network's intrusion detector model in the real environment, further research is very in need. Thanks for your listening.